Hi everyone and welcome to this video on how to change the base of a logarithm. Before we begin, please remember to like and subscribe if you enjoy the video. Remember to comment down below if you have any questions, and remember you can always comment down below a topic that you would like me to make a video on as well. The reason why we might want to change the base number of a logarithm is an example like this. We cannot combine both of these logs using the laws of logs. We also can't raise both sides to be the exponent of two numbers that are the same in order to remove the logs. So the only way to solve this is if we take the right-hand side, change that base number of 9 into 3. Let's think about how to do this. We're going to take a random variable x and set that equal to log to the base b of a, where a and b are just constants. It should be noted that none of my constants in this case are going to be equal to 1, okay, and that's because we cannot have log to the base 1 of anything. So we can take b and place it as the base number on both sides. So we would have b to the power of x is equal to a. What I can do now is apply a new log to both sides. I'm going to take a third number, in this case I'm going to pick c, and do log to the base c of both sides. I can now on the left-hand side use the power law for logs to bring x to the front. And once I've done that, I can rearrange to make x the subject of the equation. Now remembering that x was what I started with, what I set log to the base b of a as, I can see that I've managed to change that into log to the base c of a over log to the base c of b. And so we went from a logarithm to the base of b to now a logarithm to the base of c. Here's the law that I just worked out. We can see that in this expression we have three variables, a, b, and c. And in introducing this new variable c, we might complicate the question a little. So to avoid that, we can either not write it and choose to take a logarithm such as ln, or log to the base 10, where we don't write the base 10, or instead of c, we could just take log to the base a of both sides. So we rearranged our expression to be b to the power of x equals a. And at this stage, I can take log to the base a. Log to the base a of a is just 1, and on the left-hand side, I can just use the power law to bring x down to the front. So x is going to be equal to 1 over log to the base a of b. Finally, rewriting this rule, I have log to the base b of a is equal to 1 over log to the base a of b. Returning to my initial question, I can now change log to the base 9 of something into log to the base 3 of something. What I'm going to do then is apply this rule log to the base b of a is equal to log to the base c of a divided by log to the base c of b. I can see that in this case b corresponds to 9, a corresponds to x plus 6, and the logarithm should be to the base of 3 in order to match the left-hand side of the question. So this is what I would get after replacing those constants a, b, and c with what is necessary from the question. I can see that log to the base 3 of 9 is in fact 2. Rewriting 9 as 3 to the power of 2 means log to the base 3 and that base of 3 cancel out. So going back to our equation, I can now rewrite it as log to the base 3 of x is equal to a half of log to the base 3 of x plus 6. Using the power law on the right-hand side, I can now just take away the logs because they're being applied to both sides and solve my question. So I've also squared both sides here. Now I'm going to solve this as a quadratic. So I find that either x equals 3 or x equals minus 2. We must confirm if these are going to be allowed answers or not. Going back to the initial question, I can see that log to the base 3 of minus 2 is not a defined expression. We can't have negative numbers inside logarithms. So we need to cross that answer out, it can't be a solution, and so x equals 3 is the only solution for this question. Let's take a look at these examples here. We want to rewrite these logarithms with log to the base 10 instead of their current bases. Let's write down our rule that we've learnt. Log to the base b of a is log to the base c of a over log to the base c of b. In this case, we want the new logarithm to have base 10. So what we're going to do then is replace c with 10, b is 2, and a is 10. So log to the base 10 of 10 over log to the base 10 of 2. And this will be my expression in log to the base 10. I can see that log to the base 10 of 10 is just 1, so this is going to be 1 over log to the base 10 of 2, or log 2. Let's look at question B. C is still going to be 10, B is going to be 3, and A is going to be 33. So I can write this as log 33 over log 3. Let's take a look at one last example together. Here I have two logs that are to different bases. I need to change the base of log to the base x of 5 to be log to the base 5 of some other expression. Let's go back to the rule that we learned before. In this case, I need 5 to be the base, so I can use my simplified rule where I took log a of both sides. That rule at the end looks like log to the base b of a is 1 over log to the base a of b. So taking log to the base x of 5, I can see that b is x and a is 5. So what I'll have is 1 over log to the base 5 of x. Replacing that in the equation, I have log to the base 5 of x plus 1 over log to the base 5 of x is equal to 2. What I'm going to do now is a quick substitution with log to the base 5 of x equal to y. So I have y plus 1 over y equals 2, timesing both sides by y. Now I can solve this quadratic. I find that y is equal to 1, therefore log to the base 5 of x is also equal to 1. Now I can take both sides, place 5 as the base, so x equals 5 to the power of 1, which is just 5. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.